Hello everyone, we're glad to welcome you at our webinar. My name is Stacy, I represent Vettabase, and our today's topic is MariaDB Security Best Practices. The speaker is Federica Razzoli, the founder of Vettabase and the author of Mastering MariaDB book published by Pact. Just some housekeeping notes, please ask questions in the corresponding tab of the interface. Federica will answer them after the presentation is over. The recording will be sent your way after the webinar, and you will be able to revisit what's important for you. Same for the slides. We will place them on SlideShare for your convenience. And now I'll ask Federica to take the virtual stage, and we'll start.
Thank you, Stacy. Thank you for your introduction, Stacy, and hi everyone. Thank you for being here. So as Stacy said, this is a presentation about MariaDB Security Best Practices. Okay. So first of all, let me say what this talk is and what it is not. This is an overview of MariaDB best practices, so you can understand how you can protect your data in MariaDB, including some quite advanced features, actually. But it is not a tutorial. You will not see examples. You will not see how to do things in practice. And it is not an in-depth discussion about specific features, okay? Because in 1 hour, we don't have the time to discuss every single feature. So let's start right away. And the first topic is about how to restrict access to MariaDB to certain hosts and ports. Okay, so first of all, well, you don't do this via MariaDB itself, but you do it in other ways. Okay, so let's see, first of all, what you want to achieve exactly. Access to MariaDB should be allowed from other replicas, other masters, other Galera nodes, from proxies, of course, and monitoring, any monitoring tool you might be using, service discovery tools like, for example, Consul, HashiCorp Consul, or KeepAliveD, and potentially other tools. And of course, some jump hosts. When you want to connect to MariaDB yourself, ideally, you shouldn't connect to MariaDB. You should connect to one jump host via SSH and then connect to MariaDB. Proxies, service discovery tools need to be reachable from the applications, of course. Otherwise, they will serve no purpose. So monitoring needs to be reachable from the world, of course, via an encrypted connection, because it could contain some private data that you don't want anyone to see. In some cases, this could even be queries. If you can see the queries, you can see some of the data, okay? Because you can see, for example, that a query is looking for a certain email, and you will read the email in the text of the query. MariaDB shouldn't be reachable from any other node, and jump hosts, of course, should be reachable from the whole world, but only via the SSH port. So how can you do this in practice? Well, I suppose that most of you are on the cloud. So usually cloud platforms support security groups. And as a general rule, hosts in the same security group can communicate to each other using certain ports only if you set specific rules, but yeah, they can access to each other. I'm not digging into the details because it depends a lot from which cloud platform you use. If you don't run databases in the cloud, if you run them on premise, well, consider using a VPN, and it will be as safe as a security group. So the access, anyway, even if it comes from trusted servers, it should only be permitted on certain ports. Okay. So, for example, you want MySQL to be reachable via 3306 port, MySQL or MariaDB, you want it to be achievable by standard ports, including the ports used by Galera, but you don't want it to be reachable via any other port, basically. So again, you can do this with security groups. But if security is very important for you, for example, if you have financial data or very private data about people or companies, well, don't be afraid to be redundant and consider setting up rules via IP tables too, or some other similar software. Actually, IP tables is probably still the most used, but it's a bit old now. There are alternatives. Why would you do this? Well, security groups might have bugs just like any other software. So, or maybe they could be misconfigured, for example. So duplicating the rules will not be a huge problem, and it could actually save you. So up to, let's talk about Galera. Up to version 10.11 of MariaDB, Galera had no protection for a certain case, which is very important, actually. If I have access to Galera nodes and I am a potential attacker, what I can do is to install Galera, a new Galera node on my laptop, for example, and connect it to the existing cluster. Okay. As a new node, my instance will receive an SST, so a state snapshot transfer, basically a backup of the whole database. Okay, because this is what happens to new nodes. For certain SST methods, there is authentication, but if you use rsync or a file copy, well, there will be no authentication, so anyone can do this in theory. Okay, so it's very important that if you use an older version of MariaDB, it is very important that your Galera clusters run in a security group or in a VPN, which is well configured. But starting from version 10.11, we have a new option, which is WSREP allow list. Basically, it's a comma-separated list of IPs, and these IPs are the machines that are allowed to join the cluster. A couple of notes about this. Well, they can be IP4 or IP6 addresses, but they cannot be host names. The variable is not dynamic. This means that if you want to make a change, sorry, you have to do it in the configuration file, and then you will need to restart MariaDB. So basically, if you want to add a new node, you will need to restart the nodes. To avoid having the cluster down, you can restart the nodes one by one, okay? It's a rolling restart, basically. Let's talk about MariaDB users. First of all, well, I said users, and I will keep saying user for the rest of the talk, but technically we should talk about accounts, because an account is formed by a username and a host. Okay, the host can be the percentage symbol, so the jolly character, which means that the username can connect from anywhere. But still, you can have several accounts with the same username, and each of them can have different permissions and different requirements for connection. We will talk about this later. So that is why technically we should talk about accounts, and that is important. A host can be a host name, an IP for all 6, or it can be a pattern, just like the patterns used by the like operator in SQL. Okay, so you have 2 types of jolly characters. The percentage symbols means any string or even no characters at all. Okay, and the underscore means a single character, but any character. Okay, so basically in this case I have put 2 consecutive underscores. So if the host name is app01.mywebsite and so on, basically it matches this pattern, and the user can probably connect. Okay, if it is app.mywebsite, no, it can't connect. Okay, or it can also be a net mask. Okay, because the pattern is useful for host names, but for IPs, it makes much more sense to use a net mask. Okay, so a net mask is written in in one of these formats, and basically any IP in this range can connect. Can match this this pattern in this case. You probably will prefer to use IPs in cases where host name is not easy to set. For example, if you use Kubernetes for your applications. But if you have full control on your host names, well, maybe you will prefer to use the host name. It's up to you. Whatever works best for your particular case. Root is, of course, a special case. Root should only be allowed to connect from the local host. So you should have root at localhost. It doesn't make sense to require a password in this situation, right? So that is why by default, root uses authentication plugin that is called Unix Socket. Basically, Unix Socket works in this way. If you are connected to the host system, it only works on Linux and Unix. So if you are connected to the Linux system, for example, as root, then root will be your host name in MariaDB. Of course, the user needs to exist in MariaDB. Okay, but the authentication is not made by MariaDB, it is made by the system. I think it only makes sense for root, but it's good to have it. Again, please don't let root connect from anywhere else because it's obviously unsafe. You could expose root to a brute force attack. So each application or each microservice should use a different user, right? Typically, every microservice uses a different database. Even applications usually use a specific database. So they only should have permissions on that specific database. That is why it makes sense to have different users. Ensure that they can connect from the proper subnet mask or the proper host name, because in this way, again, you will reduce a lot the probability of a brute force attack. Okay, because even if I want to try to brute force the password, if I don't connect from this subnet or from this domain, I will not be able to do it. Users can, of course, connect from several places, and they can even have different permissions, as I explained before. Okay, I mean, they are allowed to do this in MariaDB, as I explained. You can have the same username associated to multiple different hosts. But usually I don't recommend to do this. If you have this, maybe it's because you don't know exactly which host name will be seen by MariaDB. Well, I understand this. Sometimes it's not easy to get, but please, I recommend to fix this situation and make sure that every username has one pattern or one subnet mask associated. I recommend to use prefixes for users simply because it makes it easier to manage them. So, for example, if your microservices have MS prefix, this will help you to distinguish them from human users. Because human users should be handled differently from applications. Let's talk about permissions. Permissions, as you might know, can be granted at several levels. Okay, they can be granted at global level, at database level. So, for example, in this example, if you have select at global level, the user can read any table. At database level, the user will be able to read any table in that specific database, okay? Or they can be at table level, or they can even be at column level. Almost no one does this, but I think it can be a very good idea to do it, and I'm going to explain why in a moment. Normally, an application or microservice should have, again, permissions on a single database. Well, or if they use more than one database, of course, they need to have permissions on all of them, but it's not ideal for several reasons. And typically, for each microservice database, it is a good idea to also have a read-only user to scale reads. Okay, basically you can send the reads to replicas, and of course you can give only select permission to the read-only user. Okay, while the normal user, the read-write users, probably should have these permissions usually: select, insert, update, and delete. You can also consider some other permissions, but usually it's not necessary. A permission that sometimes can be useful is create temporary tables, but keep in mind that if applications don't use this feature wisely, they could fill up the memory with useless temporary tables. And yes, I saw that, and I think it can happen. A special case is migrations. By migrations, I mean alter tables, especially in production. Okay. Of course, the user that performs migrations should be a different user, at least I suggest it is, because it should have permissions that the application shouldn't normally use. Okay, so create view, alter, index, and so on. All these things permit to create or drop or modify database objects. The list is not complete in this case, but well, you will find out what you need. So I said before that human users should be handled separately. And by human users, I mean data analysts, business analysts, managers, but in general, any person who should be able to connect to the database and run some SQL queries. Hopefully, in this case, the database means a replica. Okay, it is a bad idea to give them access to the master. In theory, one could argue that they should always have other ways to get the information they need. And yes, in theory that is true, but in practice, especially for small companies, most probably they don't have all the dashboards they need, and sometimes they want specific information, and the best way to give them this information is allow them to run SQL queries. So, sorry. Human users should only have select permissions and optionally, as I mentioned before, create temporary tables. In their case, create temporary tables could be a very good idea because, you know, if you run some analytics queries, temporary tables are a big optimization, okay? Because, for example, you can create a temporary table and populate it with some slow, expensive join, for example. And then you can run several queries on that table to aggregate data in different ways, okay, with different group by clauses, for example. And if you do that, at least you will run the expensive join only once. But they shouldn't have any permissions on columns that contain personal identifiable information. Personal identifiable information is not just private data. Of course, it's also private data like a person's email or name or phone or other stuff. But it's also information that is theoretically not private, like a user ID, but it could allow to identify you in the database and see that, for example, you purchased something or you performed some other action. Okay, So user ID is still PII. It is required, actually, by some legislations, including the European GDPR, that a business analyst doesn't have access to this kind of information. So how can you do this? Well, first of all, there is no magic here. I'm not going to give you a special command that you run and you obtain what you want, okay? You will have to probably write a script for that. But here's the logic that you could use. For example, you could keep a table with the list of PII columns, okay? In that table, you can store the database name and the table name and the column names. And then a script should query the information schema columns table to get a list of all the columns and exclude those that are in the PII column table, okay? And then to the remaining columns, the script can grant the select permission. Note that in theory, you don't need to include database name and table name in the PII columns table. But there is one condition. Your schema must follow strict naming rules. Okay, so you must be sure that, for example, a column that contains an email is called email, and a column that contains a phone number is called phone. If it is called, I don't know, tel or phone 1, email 2, well, this will not work. Okay, so you must follow strict naming rules. If you do, you can just have a list of columns without the table name and the database name. Now, even in this way, permissions sometimes might not be strict enough to prevent certain queries that should be forbidden, or maybe a user manages to get access somehow. Or maybe MariaDB has a security bug and the user somehow manages to take advantage of this bug, okay? So for all these cases, you can do one more thing, which is enabling the audit log. The audit log can be configured to log all the queries run by a user and all actions like connecting or disconnecting. In this way, if you find out that someone accessed your data and stole information, you can use the audit log to find out who it was, basically. You can even monitor the audit log with some specific software like Wazoo. And in that case, I mean, if you define good rules, you can be alerted, for example, if someone reads a certain table during the night, okay? And in that case, you will get an alert and you will know that probably something wrong is happening. Technically, the audit log is not necessary if you log all the queries in the slow log. Most people don't do that. It can be a good idea for many reasons, because it will allow you to investigate performance problems and even spot performance problems that otherwise you wouldn't know about. Anyway, let's go on. And the next topic is roles. So human users shouldn't be granted permissions directly, okay? because normally all human users, or at least several human users, have the same permissions. So handling lists of identical permissions is not ideal. It is a bit frustrating, and it is also error prone. So what you can do instead is to assign permissions to a role, like, for example, business analyst, this example. Okay, I'm creating a business analyst role and I'm assigning proper permissions to it. And then I can grant this role to a user. Okay. As you can see, the syntax to grant a role is the same syntax you would use to grant a permission. You can think a role as a super permission or a set of permissions. Roles can even be assigned to other roles if you have a complex data set and a complex security and permissions logic. This can be useful. So, for example, you could have a role analyst, and you could have sub roles like analyst sales and analyst employees, which basically can visualize different data. Okay. But maybe they will have some common permissions, and the common permissions will be assigned to the analyst role, and specific permissions will be assigned to the specific roles. Of course, I suggest to do this with some care. You don't want to create spaghetti roles, right? The diagram of your roles shouldn't look like a dish of spaghetti. It should be a well-designed tree. Okay. So, for example, every role can have a maximum one parent, and you should assign only the leaf roles, the leaves of the tree, the leaf roles to the users. Let's talk about authentication plugins, which is actually another very interesting topic, because authentication plugins determine how users log into MariaDB. Okay, so each user can be assigned one or more authentication plugins. Some plugins are pre-installed when you install MariaDB. Others are in the plugin dir. If in case you don't know, you have a variable called plugin dir. It is a path, and in that path you have several plugins, including some authentication plugins. And you can install them with a simple SQL command like this. Okay, this is an actual command that installs a plugin if it is present in the plugin directory. Other plugins might not be available in your, in the MariaDB package you used to install MariaDB. In that case, well, it depends how you installed MariaDB, but for example, if you used Ubuntu package, probably there could be another package, separate package that you could install to have additional authentication plugins. Some authentication plugins only need to be installed in the server, but some others need to be supported by the client. So non-official MariaDB connectors and non-official graphical interfaces probably will not support all plugins. So check the documentation to be sure. Anyway, these are the default authentication plugins. MySQL native password is actually the default one. MySQL old password is for compatibility with all the MySQL versions. And Unix socket, well, I already mentioned this. It allows to authenticate to the operating system, Linux actually, as a system user, and then connect to MariaDB without any password. Well, namepipe is similar, but it's for Windows. Actually, it's not installed by default, but it's present in the plugin there. So I want to talk about another couple of about one other authentication plugin, which is PAM. PAM is basically a set of modules, okay? Because PAM stands for Pluggable Authentication Modules, something like that. And it is a framework that can be used to implement several authentication methods, not in MariaDB, but in Linux in general, okay? And several modules already exist, and MariaDB provides more than one module in PAM. You can associate one or more modules to any user, basically, and the modules determine how exactly the user will connect to MariaDB. So, for example, there's PAM Google Authenticator, which allows to set up two-factor authentication with your mobile phone and Google Authenticator app. LDAP obviously uses the LDAP protocol, so you can use, for example, OpenLDAP for logins. And well, there are several PAM modules that allow to log in with Microsoft's Active Directory. I will be back on this later. PAM Unix simply uses system users with the passwords encrypted in etc shadows. PAM SSH in theory allows you to log in using SSH keys. I'm not entirely sure this is implemented. I mean, it is mentioned by the documentation, but I couldn't find any details, and I honestly don't know if it is possible to do it currently. It's possible, for example, that client support is missing. I'm not sure. But if you really want to know it, you can ask us to investigate. Time basically restricts the login based on the daytime, and PAM user map allows you to map several PAM users into one MariaDB user. Probably there are some others, so the list might not be complete. Actually, apparently I don't have a slide for that, but another plugin is GSS API. GSS API is basically a security protocol that is used by some Microsoft services like Kerberos, and basically it can be used to connect to Kerberos. I mean, Kerberos is a protocol, but it can be used to connect to Active Directory. So you can see that in theory you could use both GSS API or PAM to connect to Active Directory. but GSS API is more for Windows, in my understanding. It will also work on Linux, but it's something that I see as more related to the Windows world. Okay, so the next topic is SSL, because no matter which permissions you have, no matter which authentication methods you use, your connections to MariaDB should be secured, because otherwise there could be a man-in-the-middle attack. So some software could pretend to be the MariaDB server you are trying to contact, or there can be sniffing attacks. So someone could intercept your queries and the results of your queries. So starting from MariaDB 11.3, setting up SSL is finally simple, because it is done by default automatically. Okay, so when you install MariaDB, if an SSL certificate is not present, it will be generated. Actually, it will be a self-signed certificate, which is okay in most situations, in my opinion. But if you want to really be safe against a man-in-the-middle attack, well, it's better to use a certificate produced by some certification authority. Anyway, all this is not very useful unless you require your users to connect via SSH. Okay, and you can do this easily in this way. Okay, create user, username, require SSL. You can also require the user, the client, to use a certificate with certain characteristics. Okay, so you can set up a certain subject. The subject could contain, for example, the person name and the organization he works for, the city he lives in, and possibly other stuff. Actually, this depends on the certification authority. Or anyway, it depends on how you created the certificate. You can require a certain issuer. So basically, an issuer is the certification authority who emitted the certificate. If you don't specify, issuer, a self-signed certificate is permitted. And finally, you can specify the allowed ciphers. Okay, I mean the allowed algorithms for encryption. You can specify only one of them or any combination of them. Okay. So let's talk about encryption in SQL. This is probably a bit controversial topic because, well, MariaDB has several SQL functions to encrypt data. Okay, so for example, in this insert, you can see I used the crypt function with a specified salt to create a password. Okay. Now the password in this case will be sent over a network in clear. Okay, because it is written in the query. The query travels across a network, so in theory, someone could intercept it and see it. Again, if you use SSL, this shouldn't happen, especially if you use proper certificates and not self-signed certificates. But still, the possibility exists. Okay. MariaDB 11.2 actually improved another function that is AES encrypt and also AES decrypt. These functions already existed for a very long time, but now they added two parameters, the vector and the encryption mode. If you specify them, it will be even safer. Check the documentation and check the Wikipedia pages about the vector and I mean the AES vectors and the AES encryption modes. But it's important to notice that the second argument is the encryption key. The key can be passed by you. It can be a string, but now there is also one additional function that is keepdf, which basically generates good encryption keys. It's not really implemented by MariaDB. It calls a function that is provided by the OpenSSL library. Okay, so if you use it, you will generate safer keys. But basically, if you want to do this, it doesn't make much sense if you store the key and the encrypted data in the same database server. Okay, so if you do this, you should store them in separate database servers. Not just separate databases. Because if I get access to a database, I will get access to everything it contains, probably. It could sound a bit complicated, but if you care about it, probably you have very strict security needs, so probably it is worth it. Now let's talk about encryption at rest. Okay, actually, before talking about encryption at rest, there is a very similar topic. I don't have a slide for it, sorry, but I will mention it very briefly. I will just mention that it exists. And it is a InnoDB feature that is called data scrubbing. Basically, when you delete data, any data, even when you delete a file, basically, the space on disk is deallocated, so it officially doesn't belong to a file anymore when you delete a file, right? It's very similar when you delete data or even a table inside MariaDB. The disk space is deallocated, but it's not overwritten. It's still there. Eventually, at some point, if you continue using the disk, it will be overwritten sooner or later, but not immediately. So if I manage to steal a disk, I can use specific software to find data that should be deleted, but was never overwritten. Data scrubbing basically scrubs the bits of the hard disk, overwrites everything, and basically makes the data impossible to recover. It is a feature that sounds very cool, but it can affect performance. So you should make some tests before enabling it. Anyway, yeah, as I said, encryption at rest is a related topic because it is the encryption of data written on the disk. Okay, not deleted data, the data that is actually in use, but it's written on the disk. Why is it useful? Well, because someone could gain access to the operating system and see the physical files, but maybe that's not very likely. But another possibility is someone steals a disk. You might think that it is impossible because you use Amazon Web Services or something like that. Well, if you think about it, if someone who works at an Amazon data center finds a way to steal a hard disk, well, it's a high risk for him, but that person will become rich if he steals the right hard disk. Okay, if he steals the hard disk of a financial organization, for example, data can have a big value. We all know that. So if we encrypt data on disk, that data will be unusable, provided, of course, that the disk doesn't also contain the key to decrypt the data. Okay. Anyway, disk data can be encrypted in many ways. Doing it in MariaDB is not the only way to do it. In theory, you could do it with some file systems that support encrypted data, or you could do it with some specific hardware. Maybe it will be even faster, but it will not be standard. Okay. MariaDB provides a way to do it that works no matter where you run MariaDB. Okay, no matter on which system, on which file systems, on which hard drives. Okay. So what does MariaDB encrypt exactly? Not everything. Okay, there are things it doesn't encrypt, but it encrypts IBD files, so basically the data and index files for InnoDB, the IB data and IB log files, and basically these are the system table space and the redo log. The area data file and index files, the binary log files, the relay log files on the replicas, and temporary files that might contain, for example, long transactions or are used to sort data on disk to run certain types of queries. But as I said, there are things that are not encrypted, and the most important thing that is not encrypted is Galera cache. Okay? Galera cache contains recent data written by each Galera node. And the fact that is not encrypted means that it could be possible to use the Galera cache to rebuild the data. I mean, not the whole data, but at least a portion of the data. The slow log and the general log are not encrypted. Is this a problem? Well, potentially yes, because as I said before, if a query looks for a certain email, that email address will be written in the query. That is only an example, of course. The audit log, it's a problem for the same reason. The error log, usually the error log doesn't contain any sensitive information, but sometimes it contains queries. Area log, but this is only relevant for non-temporary tables. Okay, temporary tables are not logged. And other storage engine files. And also the FRM files are not encrypted, but honestly, I don't see this as a problem because it's only metadata. I mean, someone can see that you have a table called user with an email column, but they will not know which emails are contained in that column. So basically, to sum up, I would say that MariaDB encrypts everything if you use InnoDB only. Area is always used for temporary tables, but if you don't use it explicitly for regular tables, it won't be a problem. But the slow log and the logs in general and the Galera cache especially will not be encrypted. Is this a problem? Well, to be honest, in most situations, I wouldn't see it as a huge problem, but it depends on which company you work in and which type of data you manage. Okay. So, as I said before, it's vital that you don't store the key in the same hard disk that contains encrypted data, because it's like encrypting something and providing the instructions to decrypt it. It's not very smart. It's also important that the keys are rotated. You don't want to use a single key, and especially, I don't know, a key could be stalled maybe in some cases, or, well, key rotation is always a good thing. And to take care of these two things, we have to use, it's not optional, a key management plugin. There are 4 according to MariaDB documentation. The first one is the simple one that is provided with MariaDB and doesn't require any external service. It is the file key management plugin. I will talk about it in a minute. The HashiCorp key management plugin uses Vault, but HashiCorp Vault is, well, some time ago I would have said open source. Now it's technically not open source because they are using the BSL with a clause that makes the code not open for cloud providers, basically. It doesn't affect the final users. Maybe you don't care about it. Personally, I don't care about it, but some people do. So I want to let you know that technically it is not open source. And the other 2 are Eperi and AWS. AWS plugin is not distributed with MariaDB. I'm not sure about the Eperi plugin. Anyway, they require external services that are not free, so I won't talk about them now. I mean, we could support them, of course, if it's if you want us to, but I'm not going to talk about them in this talk. So the file key management plugin is very simple. It supports multiple keys, but it doesn't support any key rotation. And the keys are stored on the same server, and they can be manually encrypted. Okay, so the keys can be encrypted, which is good, but you have to encrypt them yourself. HashiCorp key management plugin, as I said, requires HashiCorp Vault, and basically the keys will be stored in HashiCorp Vault. You can use multiple keys. Key rotation is supported, and basically MariaDB will retrieve them using token authentication. Okay, so MariaDB needs to know the token to connect to HashiCorp Vault to be able to get the keys. It's interesting to note that encryption at rest is a great example of how MariaDB is enriched by community contributions, because it was originally implemented by Eperi, and then tablespace encryption was implemented by Google. Backup security, I think this is the last topic actually. Physical backups are encrypted if you are backupping encrypted data, of course. But if you are encrypting any other data, I mean, not encrypted data, or if you are not using physical backups, if you are using a dump, for example, the data is unclear. So you should take care of backupping the, you should have care to encrypt your backups yourself. It's easy, you can do it, but keep in mind that it takes some time, and that is important when you have to restore a backup, because you lost your database, okay? So all your databases are down and you need to restore data as soon as possible. If your databases are big, unencrypting them will take, decrypting them will take time, and maybe this is not what you want. So sometimes, of course, you have to choose a compromise between, a trade-off between speed and security. If you decide to encrypt them and also compress them, first encrypt them and then compress them. Okay, and then of course do the opposite when you have to restore them. If you send backups to other locations, make sure to use secure connections. Okay, because someone could intercept connections that are not secure. And if you keep backups on a physical location, in your office maybe, well, make sure that your backups are stored securely. Okay. Make sure you also transport them securely if it is relevant. For example, I know of one CTO who personally used to take backups to the bank every week. But if someone knew about that, they could steal the backups while he was going to the bank. Okay. Anyway, this was the last slide. So the talk is finished. I don't have anything else. I don't know if there are questions.
Except for the one, the attendee who has joined us late is asking if he can get a recording, and surely we will provide it to everyone who has registered. And I also want to thank everyone for your interest in our event. We are glad you were attending it. And thanks to Federico for covering this interesting topic. As I have said previously, you will get access to all webinar materials, including the presentation and the video recording. And by the way, next month we are going to host a joint webinar with our partner, MariaDB, a metadatabase that enables running predictions and uses traditional databases as external data sources. We'll discuss how MySQL users can leverage MariaDB features without a data scientist, using only SQL queries. If you would like to query your future data for some reason, this webinar is for you, and it will take place next year on January the 17th. So we hope that some of you will join us then, and we'll send you a link via email. And the link is also in the Q&A section, so you can register right now.
Great.
Yeah. Any
Thanks.
questions? Oh, I see the question. Carl is asking, for Galera, could you mention again the SST methods that are vulnerable? Is the Maria backup SST method vulnerable?
No, Maria Backup is not vulnerable because it requires a user in MariaDB, so you have to provide user and password. And sorry, I was going to say MySQL dump, but of course I mean MariaDB Backup is the same. It requires a user and a password to connect to MariaDB. But rsync doesn't require any authentication. Oh, and by the way, hi Carl, it's good to have you here.
No questions for now.
Okay. Maybe there aren't any, so yeah. Yes, I talked too much and people are tired now.
It was essential information anyway.
Mm-hmm. Yes, I think it was.
So if there are no other questions, probably we will wrap up.
Mm-hmm. Okay, cool.
So thanks again, everyone, and goodbye. See you next year at our webinars.
Thanks, Stacy, and thanks everyone, and bye.